Alrighty, so you had a little bit of time to look at the yellow sheet and try to get your answers figured out. I'm going to go ahead and show you the results of each one. You can pause the video if you need to and kind of read over and see if you came to the same conclusion. So number one here, it says the limit is the ratio of the coefficients of the highest powers in the top and bottom. I had a nice succinct way of saying that. You may have needed to, a little bit more space to describe. But it turns out, right, in all of these, the general idea is that if you look at the highest powers in any of these problems, right, that's how you're going to get your limits figured out. So for 1 through 4, right, look at these are all the same degrees on all of these, so these answers here are simply the coefficients of the highest powers, taking into account the negatives or as the minus signs when they appear, right, to get -4/3. 5 and 6 are super awesome because this is the best kind of question because the answer is always 0. Because you're effectively, right, having a really small numerator and a huge denominator, because a power of 4, when you raise a number like 1,000,000 to the 4th power, is significantly larger than if you just happen to square 1,000,000. Okay, so it turns out 5 and 6 are easy that way. 3 is maybe where you struggle the most. This pattern isn't as evident, but excuse me. What you need to do in order to get these problems correct is same idea. You want to focus on the largest terms in the top and bottom, but what you have to do for these problems is actually take the 2x cubed divided by x and get that resulting term. So that would be 2x squared is what that simplifies to, and plug in infinity, right? Think about what you get when you plug in infinity of this. Since I square it and multiply it by 2, I'm getting an even larger number. So we're going to write positive infinity for that. If I plug in a really large negative number, again, I square it, turning it positive, and then multiply by 2, so that's why I'm going to have a positive infinity here as well. In number 8, our coefficient happened to be negative, right? So that affected this totally different, okay? So we do know that these two are going to match. Darn bell. They're going to match whenever you have an even power, so that's one thing that you can note. And then they're always going to be kind of opposites of one another when you have an odd power. Okay, but the same thing in 9 and 10. You're going to take the -3x cubed and divide it by -3x squared, resulting in just the variable x. So when you plug in infinity to this, you're essentially getting infinity out. When you put in negative numbers, you get negative infinity out. And then here you have -3x cubed divided by 3x squared, simplifying to -x, causing these same signs to change. Okay, so these patterns are super awesome because it's really helpful in terms of helping you figure out these limits, so you don't have to like actually do tables or anything like that. And the thing that you may or may not caught on, and some of you may have remembered from last year, right, is that all of these limits in 1 through 6 are turning out to be the horizontal asymptotes of the function. So graphically, that's what's going on. We'll talk more about that later. And then number 5, we can have a variety of answers. The big idea is if I were to give you a highlighter and you highlight your biggest term on the top and bottom, do they have the same degree, and is the ratio of their coefficients 5/6? If it is, you did a great job. If not, just kind of cross it out and redo it. Okay, even if these were both, if this was a minus sign and this was -6x cubed, that would be great. And your function is probably much simpler than mine. No, I just like to spice it up a little bit. Okay. Thanks.